Build a tiny language AI from scratch. Part 2. Inside the network. Weights, biases, ReLU, and Softmax.
Here is the whole machine. 80 input values are 2 one-hot words, a hidden layer of 32 neurons, and an output layer with 1 neuron for every word in the vocabulary, about 40 of them. Neuron 22 might stand for learn, neuron 7 for blue. The network's answer is simply which output neuron scores highest. And why 32 hidden neurons? Nothing magical. It's just a small number that works. You could try 8 or 64 and watch the behavior change. The connections between layers are called weights. W1 is a grid of 80 by 32 numbers. Every input position connects to every hidden neuron, and each connection has its own strength. A positive weight excites the neuron it feeds. A negative weight suppresses it. These numbers are where all of the learning will eventually live. And here's the humbling part. They start out completely random. Before training, this network knows absolutely nothing.
2 small details about that randomness. First, we set a random seed, 42, so every run starts from the same random numbers. That makes experiments reproducible. Second, we multiply the random values by 0.1, keeping them small, gentle nudges rather than wild swings. Each neuron also gets a bias, an extra adjustable number, starting at 0. Think of it as a threshold knob. Weights decide how much incoming signals matter. The bias decides how easily the neuron fires at all. Then a second grid of weights, W2, 32 by 40, connects every hidden neuron to every output word. So the network has exactly 4 bundles of learnable numbers, W1 and bias 1 from input to hidden, W2 and bias 2 from hidden to output. That's it. When we say the network learns, we mean these 4 bundles of numbers change, nothing else.
Between the layers sits a function with an intimidating name, ReLU, the rectified linear unit. The rule is almost embarrassingly simple. If a number is positive, keep it. If it's negative, replace it with 0. So the hidden values, negative 0.7, 1.2, negative 0.1, 0.8, become 0, 1.2, 0, 0.8. Some neurons go silent, others stay active. Why bother? Without this nonlinearity, stacked layers would collapse into one big linear formula. ReLU is what lets the network build genuinely complex patterns.
At the output, the network produces raw scores. Is 3.7, learn 2.4, blue 1.1. Useful, but they're not probabilities. Softmax converts them. Is becomes 61%, learn 20%, blue 12%, and everything sums to 100. Now the output has a clean meaning. Which word does the network believe comes next, and how confident is it?
One engineering footnote hiding in the Softmax code. Before exponentiating, we subtract the largest score from all of them. Why? Softmax uses exponentials, and e to the power of 1,000 overflows any computer. Subtracting the maximum first keeps the numbers tame, and beautifully, the final probabilities come out identical. Small trick, same math, no crashes. The machine is built. Next episode, we teach it, with loss, backpropagation, and gradient descent.